Hello, I'm Sheila Donegan from Maths Week Ireland. Welcome to day 5 and the last day of Maths Week TV. Maths Week has been a huge success this year. Already we've had over 360,000 pupils registered by their teachers as taking part in special Maths Week activities. Teachers, if you haven't already registered your pupils, please register on mathsweek.ie. We've seen amazing creativity on Twitter and Facebook from school all across the island. So keep posting on social media and show us what you've been doing for Maths Week. Today, the 16th of October, is Hamilton Day. It's the most famous day in Irish mathematics. It was on this day that William Rowan Hamilton, Ireland's greatest mathematicians, discovered quaternions and the equation for quaternions as he walked along the banks of the Royal Canal from Dunsink Observatory to the Royal Irish Academy in the centre of Dublin. He'd been working on this problem for a long time, and suddenly as he walked along the canal he got a flash of inspiration and solved the equation. And he famously scratched the equation on the wall of Broome Bridge. This Hamilton Walk is commemorated every year by the Hamilton Walk, which is coordinated by Maynooth University. Today, we are celebrating this famous event with a virtual walk, which can be seen live at 2 p.m. on the Maths Week website. Today's episode of Maths Week TV is brought to you by James Tanton, founder of the Global Maths Project. James is based in the US and he's the mathematician in residence at the Mathematical Association of America. James believes that mathematics really is accessible to all, and he's committed to sharing the delight and beauty of the subject, as he gives talks and shows all across the world. So let's welcome James.
G'day everyone, I'm James and happy Irish Maths Week. I hope it's been a spectacular week so far. I'm actually in Phoenix, Arizona, very far away from Ireland right now. I'd love to be there too. And by the time you're watching this video, it's actually 2 o'clock in the morning for me here in Phoenix, Arizona. So actually you're not seeing me live. I'm actually making this recording at 9 o'clock in the morning, which is something I can manage to stay awake for. But I'm going to pretend I can imagine seeing all your fabulous faces on this Zoom call and give a little experience right now in joyous mathematics over Zoom as though I'm with you right now. So hopefully this feels real, hopefully this feels genuine, because in my heart, in my mind, I'm doing actual, real, genuine mathematics with you today. In fact, it's about a little problem I have when traveling. It's about these things, because when I travel to go give talks and lectures and so forth, I need to look good and proper. So I usually wear, a proper shirt and a tie. But I have trouble. So for example, if I were catching a plane from America to Ireland right now, I'd have to pack my tie. Now, of course, I could lay it out flat in my suitcase. Well, the trouble is I can't lay it out flat in my suitcase because that's way too long. It's even off the screen. So what I have to do is fold it. Okay, that would fit in my suitcase. But the trouble is, I don't like big, heavy luggage. I actually like just carrying my luggage by hand. So I like small cases. So this is even too long for my usual hand luggage. So what I say then, okay, if I need to pack my tie, I'll just fold it in half again. So that makes quarters. And that definitely fits in my luggage. I can fit it in my luggage. But then I have a problem. Because when I unpack my tie after a very long trip, you'll see it got folded right there, which is at the 1/4 mark. So when I put my tie on the next day, you're going to see this very embarrassing crease mark right in the middle of my chest, which is very embarrassing. I don't want a crease mark in the middle of my chest when I unpack my tie. So here's the thing. I thought, well, actually, maybe there's a way I could actually fold my tie into perfect thirds. And I don't quite have a perfect third there. I'm a little bit off. But if I could do perfect thirds somehow, then that would be still the right length to fit in my hand luggage. That's good. And also the crease mark would happen right at my neck where I tie the knot and no one would see the crease mark. So here's my challenge for today. How could I fold a tie into perfect thirds? Or maybe so close to a third that the human eye couldn't tell the difference. That's my challenge. Is it possible to fold something like this into thirds? And the answer is yes, sort of. In fact, you get so close that the human eye really can't tell the difference. But I want this to be a hands-on experience. So I'll just fumble for the next 30 seconds or so. If you can find like a floppy thing, like a tie or a shoelace or a piece of string or something you can fold right now, quickly go grab something you can fold, because I want to show you a technique for folding things into thirds, or really close to a third. So I will just pause for 30 seconds. I'll count to 30 or something. This is going to be very boring for those people who have something in hand. It's probably about 5 seconds went by just then. 1, 2, 3, 4, 5. That's 10 seconds gone by. So try to find something floppy, be it a string, a shoelace, a very floppy zucchini or something. No, you can't fold zucchinis. There's probably another 10 seconds went by. Keep finding something. Try to find something. So I actually want to try it, you to try it too with me. Is that 30 seconds? We'll say that's 30 seconds. All right, I'm back. All right, so here's the technique that you can hold, how you can fold something into thirds, or so close you couldn't tell the difference. What you do is the following. So you can copy me right now if you want, or just watch for the moment and then try it again in a moment. So what I'm going to do is I think I have to stand up so you can see it. So let me move my chair out the way. All right. I'm going to do is make a really bad guess at what 1/3 is. You see that? Oh, that's like how long that tie is. That is a really bad guess at 1/3. So there's a bad 1/3, which means the other side must be a really bad 2/3. So let's pick up that long side and fold that in half. See, I'm folding it in half. Great. Now I'm going to put my fingers in the loop there, hold it tight on that loop, and drop everything else. Whoa. Then I'm going to pick up the new long end, pick it up to the top, hold everything at the top, put my fingers in the loop, and drop everything else. I claim that this is now closer to being 1/3. Whoa. In fact, if you want to make it even closer, still do it again. Pick up the long end, hold everything at the top in one hand, find that loop, put your fingers in it, and drop. Pick up the new long end, which is this one, fold it in half, hold everything at the top, put your fingers in the loop, and drop. And I claim that is even closer still to being 1/3. In fact, I think I can probably show it on the camera. I'll show it on the camera. So that is what I think is 1/3. And if I fold it all up into what looks like thirds, whoa, that is really quite close. That's amazing. That's very close to 1/3. All right. Okay, so I'm not quite sure if my standing up technique was good then. So let me do this. Let me do it on a piece of paper and show you again what just happened. And I need to just actually get my camera to share my screen. Share my screen. Let's look for this. Whoops, no, that's the wrong thing to share. I need to share a particular application. Show all the windows I'd like to share. I'd like to share this window, please. All right. Hopefully now, yes, you can see a strip of paper. Let me get into focus. Strip of paper on a piece of white paper. So there's yellow paper on a piece of white paper. Come on, camera, please focus. Please focus. There we go. All right. All right, so here's what I did. So I'll do it on this piece of paper right now, what I did. First of all, I made a really bad guess at 1/3. I have a feeling that's a very bad guess at 1/3 of the way along. And here's the technique we did. We picked up the long end, folded it in half, and you can fold in half fairly accurately, actually. Folding in half seems to be fine. We made a crease mark, but that crease mark is, just in case you can't see it, is right there. Great. And then we picked up the new long end, that's where we were holding, and fold in half again, and get a new crease mark. And now we've got a line over here, which does look like it's closer to being 1/3 than it was before. In fact, to make it better still, we'll do it again. Pick up the long end to the crease mark we just had, right there. All right, don't think you can see that, so I'll put some dotted lines there. Now pick up the new long end, which is this side, to the crease mark we just made. Beautiful. And actually, we now have a mark right there, which I claim is even closer to being 1/3. In fact, let me do that. Let me fold it right there and fold the piece of paper on the rest of it. And I think you can see it is really, really close. You see that's really close to being 1/3? Pretty accurate. That's amazing. That's amazing. Whoa. So maybe you now do want to try it. For dedication, I'll stop sharing my screen. For dedication to this cause, I actually took an old tie of mine and chopped it short so it actually would fit on the camera. So here's the technique. So here's a short tie that I think will fit in the camera. We made a really bad guess at 1/3. That's a really bad guess. You do, pick up the long end. Bingo. Look at the crease mark, drop. Pick up the long end, fold it in half. Go to the crease mark, hold there, drop. And I claim, it's a bit crinkly, but that's close to 1/3. And to make it better still, do it again. Pick up the long end, fold it in half. Look at that crease mark, drop. Pick up the new long end, fold it in half. Look at that crease mark, and drop. And make it better still, do it again. Crease mark, drop. Long end, half, crease mark, drop. And I have a feeling that is very, very close to being 1/3. And if you actually, whoops, if I can hold on the camera, it looks really, really good. Really, really good. But you can see the tippy point of the tie is right near the edge of that corner. That's pretty amazing. All right. So that is actually kind of fun to do. Maybe you did it too just then with whatever floppy thing you're holding right now. But now the question is, why does that work? What's going on? Actually, it's possible to explain what's going on. And let me do that now by sharing my screen yet again and going back to that piece of paper. So where is it? There it is. There's my screen back here. There's the piece of paper we had before. So here's what we're doing. I'll get a fresh piece of paper this time. So we made a guess where we thought some length was. So maybe this is some length L. So we were thinking 1/3 at first, but maybe you want to go to some other fraction. Some length L. But we're humans. We are certainly going to have some error. So there's going to be a length L with some error. Now think about what happens whenever you fold something in half. If this is L plus some error, and you fold in half, now folding in half we can do fairly accurately because actually we're pretty good at folding in half, then you'll get two lengths. You'll now get this length to the crease mark and that length to the crease mark, which must be, well, half and half of that length L plus error. Oh, so this must be half the length of L plus error, also divided by 2. Half of L plus error will be L over 2 plus error over 2. And this will also be L over 2 plus the error over 2. My point is, whenever you fold something in half to get a new crease mark, you've actually made the error go in half. Listen to that. Every time you fold something in half, the error gets halved. That's the key. Every time you fold something in half, you halve the error. So let's look at that. So here is what I did with the tie and a bit of paper. You make a bad guess. That's a bad guess at 1/3. But that's 1/3. And we think that's 2/3. But there's going to be error. Whenever I fold this in half now, as soon as I fold something in half, I'm saying, that must be 1/3 with half the error, which means this is 2/3 with half the error. Fold in half again. This now must be what I thought was 2/3. Now it must be 1/3 with half the error, half of half the error. Do it again. This is 2/3 with half of half the error. Fold it again. This must be 1/3 with half of half the error. Do it again, because I think this is now 2/3 with half of half the error. One more time. This must be 1/3 with half of half the error. That's 1/16 the error. That is 1/3 with 1/16 of the error. And if you do this as many times as you like, we can make the error go as small as we please. So small that the human eye couldn't tell the difference. This is why that technique works. Wherever you think you are, if you've got some error and you fold in half and reassess where you are, you'll be correct with half the error. We always keep halving the error every time we fold, which is stunning and beautiful. Because now I'm going to stop sharing and reveal another piece of information to you. When I was telling the story, I just chose the fraction 1/3 because it sounded good and easy to work with. But here's the truth. I actually decided that the best fraction for my chest is actually 4/7. I want 4/7 of the tie. I want the crease mark at 4/7. So here's my challenge to you. How can we fold a tie at the fraction 4/7? Here's the fraction. I'll hold up to the camera. That fraction, hopefully it's the right way around, 4/7, or at least so close that the human eye couldn't tell the difference. Can you think about how you might do that? I'll give it just a couple of seconds here, because then I'll give it away. in a moment, but I want you to think first. Can you do 4/7 somehow? All right. So, okay, here's the strategy. Here's the strategy. So take your floppy thing. I'll use my short one here. Here's my short one that almost fits on the camera. Step one, make a really bad guess at 4/7. I think that right there, this one, I guess, okay, 4/7, the other side must be 3/7, so it's slightly longer. So this is, I'm going to make a bad guess that is 4/7. Bad, I'm sure it's horrible and wrong. But here's the idea. What you do is you pick up one end that you can halve. Now, I don't like thinking about fractions too hard, so I'm going to choose the fraction that seems easiest to halve. I could either halve 3/7, or I could halve 4/7, because half of 4/7 my brain can do. I can do half of 4/7. It must be 2/7. Oh, so that must be 2/7 with half the error. We halve the error once. Okay, if that's 2/7 and that one's 5/7, which one's the easier one to halve? Well, my brain says I can halve 2/7 much more easily. So let me halve 2/7. Now I've got, oh, that should be half of 2/7, 1/7, with half of half the error. We did 2 folds, therefore half of half the error. Now I've got 1/7 and 6/7. Well, which one's easier to fold? Well, half of 1/7, but half of 6/7 my brain could do. Half of 6/7 is 3/7. So there's a third fold, so that should be 3/7 with half of half the error, 1/8 the error. Oh, and we lucked out, because if that's 3/7, that must be 4/7, which is back to the fraction I wanted. So this is closer to 4/7 with half of half the error. Wow. But I want to be even more accurate, do it again. Half the easiest side, half of 4/7 is 2/7. That's fold number 4. I've got, what have I got? 2/7 and 5/7. 2/7, I'm going to fold that one in half. Half of 2/7 makes 1/7. Beautiful. Drop. So I've got 1/7 and 6/7. Okay, 6/7 is easier for me to halve, so I'll do 6/7 to 3/7. Uh-oh, how many folds is that? 1, 2, 3, another 2 folds. We've just done 5 folds. So, oh, we did 6 folds, because that's 3/7, 6, my fingers. 6 folds. This is meant to be 3/7, which means the other side's back to being 4/7 with half of half of half of half of half of half the error. Oh, what's a half of 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 a half? Half of a half of a half is an 1/8. Another half is a 16th. Another half is a 32th. And another half is a 64th. All right. I bet this is so close to being 4/7. Your human eye couldn't tell the difference. 64th, the error I started with, that's going to be very, very small error. That's brilliant. That is brilliant. All right. Okay. Actually, let me reveal something else to you. You know, when I really was doing this, it wasn't the fraction 1/3, because I just said I chose the fraction 1/3 to make it an easy start for us. And it really actually wasn't the fraction 4/7, because 4/7 is a bit too long. That's more than a half of the tie. The actual fraction, when I actually sat down and measured my chest and actually measured the length of my tie and what part of the tie I'd like to have showing on my chest when I'm wearing a proper jacket and tie and shirt and all the rest, I decided that the best fraction for folding for my ties and on my body is this fraction. You're not going to like it, but this is what I came up with as the best fraction for me and my ties. 19/37. Can you fold a tie into the fraction 19/37? And here's what I'd like you to do. I'd like you to start by making a really bad guess. Okay, that would be an atrociously bad guess. Doesn't matter. This is bad guess at 19/37, which means the other side must be 18/37. Is it 18? All right. Then all I want you to do is just keep folding the side of the tie that's easiest to do arithmetic on. Half of 19/37, half of 18/37 is 9/37. In which case I could do that one. Beautiful. Now I'm at 9/37 with one fold, half the error. Can you get this tie, make a bad guess at 19/37 and keep going to get me a fraction that's much, much closer to the true position of 19/37 on the tie? This might take a little while, but it's actually worth doing it. And I'm actually, and I mean it this time, I'm going to pause for 4 whole minutes. So I'm just going to sit here and twiddle my thumbs and let you have a go at trying to do 19/37. Good luck. Actually, I won't make you do all the work. I'll do it too. I'm going to do it too in a different way, but you keep trying to fold your tie because we've got another 3.5 minutes to go. But I will do a little bit of work on the side here while you're doing that. How's it going? We've still got more time. Trying to fold into 1937ths. Are you getting lost? Have you kept track of things? Still got more time. All right, all right. Let me help you out. That was long, and maybe you're just sitting there waiting for me to start talking again. This is a tough one. This is a tough one. I mean, you can do it, but you get lost so quickly. Okay, make a bad guess at 1937ths. This will be 1837, so let's halve that one to 937ths. If this is 937ths, that means the other side is 2837ths. Half of 28 makes this 1427ths, 37ths, and so on and so on. And you do this for a very long time. I decided, you probably heard me squeaking away with my pen, not to do this with a tie, but to do with actual paper. I did it with actual paper. In fact, let me share the screen so you can see what I did. I wrote out all the fractions that you get as you do tie folding. And here's what I got. Does it even fit on the screen? Oh, this is so big. Maybe I should make this, can I make this bigger? I think that works. I think that's showing. All right. Yes, I did start with the fraction 1937ths, and I wrote the other side was 1837. So I halved the 18 to 937ths. The other side was 28. 28 I halved to get to 1437ths and 2337ths. Halved the 14 to 737. I kept doing this halving, 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 halving. All right, but you see, I kept doing this, and I was doing this for a very long time. Very long time. And I started getting to the point where I was wondering, will we ever get back to start? And look, there's the fraction 1937ths. It took 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 folds. 18 folds, and I lucked out. When I started at 1937s, I did manage to get back to 1937s again after 18 folds, which means I halved, 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 halved the error. So that's got, the error there has to be so, so small, which means that number has to, our tie right then would have to be so close to the actual fraction 19/37 you couldn't tell the difference. Whoa. If you're really observant, you might notice that the 19/37 is on the wrong side. We start with 19/37 on the left here, and we got to 18/37 on the left and 19/37 on the right. So actually, if I kept going for another 18 folds, I'll be back to 19/37 at the beginning. Whoa. This is crazy. This is crazy. So what's amazing to me is that this method actually works. For example, let me stop sharing the screen. There is a possible worry that it won't work. For example, we seem to be very lucky that we went on a journey that took us on these fractions that did actually make us go back to start. We went back to start. But what could happen, with what I'm wondering, how do I know if I start at one fraction, I'm guaranteed to ever see that fraction again? Because it's possible I could start at my fraction I want. See if I can do this on my chest so you can see what's going on. I could start some fraction I want. I could do all this folding, fold, 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 go on this great big journey of folding, and actually enter a cycle and then just keep on going. Keep going on the cycle. Whoops, I can't draw it very well. Never actually see the fraction I want. I could start at 19/37, fold, 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 get some fractions, 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 and never actually go back to 19/37 and get stuck in a loop away from 19/37. And actually, you know what? That will never happen. Whatever fraction you start with, you are guaranteed to see that fraction again, which is amazing. And I can kind of explain why. Because look at this one. Suppose I get to some fraction, boom, that then later on I come back to that fraction, which means this fraction came from two possible starting points. It came from a fraction up here, and it came from a fraction up here. The thing is, no tie folding has two fractions as parents. For example, here is, say, 2/7 and 5/7. You know where this came from. It either came from 2/7 was the result of halving 4/7, or 5/7 was the result of halving 10/7. But you can't have 10/7. So this must have come from 4/7. And that's where that fraction must have come from. Only one possible place it came from. Again, now if this is 4/7 and this is 3/7, where could this have come from? Well, it came from halving, which means this 3/7 either came from 6/7 that got halved, or this 4/7 came from 8/7 that got halved. That's not possible. You can't have 8/7. So this must have come from 3/7 that got from 6/7 that got halved to 3/7. It must have come from that. So every fraction you experience can't come from two different places. It can only come from one place. Therefore, you'll never actually go to a loop where you have a fraction that came from two different places. You are guaranteed to go back to start. This method will work. It is amazing. It is amazing. All right, all right. I'm going to end off. My time is pretty tight now to say, all right, let me try something very sneaky and different. Instead of doing it with ties, where I can have creases at anywhere I like along the tie, what if I did this with like lollies or something, or candy, or whatever country you might say lollies, you might say candy or sweets. Let me share my screen again, and let's try another experiment to end off with. Okay, so here's some candy. Here's some candy. Sweets, lollies, whatever you want to call them, whichever country you're in. And suppose I need to share this amongst 7 children. And they're going to be very particular about getting the right amount of candy. So I'm going to say, okay, I want 1/7 of the candy over here, and I'll share the rest of it later on to the other 6 children, but I need one child to get exactly 1/7 of this candy, or so close. And I don't feel like counting this. So let's see if we can use the tie folding method on this sort of example. So how did the tie folding method begin? Well, it said, okay, make a very bad guess. First thing to do is make a bad guess. I have a feeling that's a really bad guess. 1/7, 6/7, terrible, terrible guess. That's okay, because the technique says, all right, take the biggest length you have, or the biggest pile we have this time, and halve it. So let's do half. So that's something like that. Now, I'm not actually going to count. I'm not going to actually count exactly half. I'm going to eyeball it. So there it is. There's half. So this is 1/7 allegedly. This is 6/7, but now I'm halving it. So this should now be 3/7 on this side, 3/7, and there should be 4/7. Now, what's the tie folding technique to do? Halve the easiest side. 4/7. I can do half of 4/7. It's about that. All right. I didn't actually count. I'm just eyeballing it. But now that should be 2/7, which means the other side is now 5/7. All right. 2/7 and 5/7. Which one's easiest to halve? I know this one. This one's about, is that about half? Okay, beautiful, halve it. So this should be now 1/7 and 6/7. Okay, that was 3 halvings. That was half, half, half. This should be 1/7 the pile with half, the half, the half. 1/8 the error I started with. So this should be really close to 1/7 of the pile. Okay, is it? Let's check it out. So I need to know how many pebbles I have. 2, 4, 6, 7. Okay, there's 7 pebbles on this side. Also, if this is 1/7, that means I must have 49 pebbles. It means there should be 42 pebbles here. I'm actually not sure how many I started with. Let's find out. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh, a 10, 10. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's 40. Oh, 42. I actually had 49 pebbles here. And in my very rough guessing right then, I had 42 on this side, 7 on this side. Yes, I actually got to 1/7 of the pebbles. This is amazing. All right, so there is my presentation for today about how to fold things not just into thirds, but also into 7ths or 4/7, or something crazy like 19 or 18, 37, whatever fraction you want. You can do it and be as close as you want by using this technique. I think mathematics is just astounding and fun and marvelous. I really love playing with maths, both actually physically playing and intellectually playing, because that's what maths is. It's actually a joyful, creative pursuit. Thank you so much for letting me talk with you today, and I hope this was actually interesting and fun. And now you're all set to go fold all sorts of things. All right, thank you, everyone. Bye-bye.